Hey folks, we are going to look at example 7. This is at the end of section 3.2 notes. Section 3.2 notes. This is height of a projected object. You'll notice that I have a standard equation right here. It kind of looks like our f of x equals ax squared plus bx plus c, except that my a is a negative 16. My b, this is what we call a v sub 0, and then my c is an s sub 0. Other than that, the only last difference is that my x's are no longer x's, now they're t's, and my f of x's are s of t's. But really, it is the same formula, the same equation that we've used in the past. Notice that my s, or you could call it my s of t, this is my height, always measured in feet. S sub 0 is my initial height, or my starting height. V sub 0 is my initial velocity, or my starting velocity. T is always measured in seconds. It's a time value. The middle two, these are always going to be given to you guys. The S sub 0 and the V sub 0, this will always be handed to you. So take a look at our example. You have a ball that's being thrown directly upward from an initial height of 100 feet. So we know that this right here is going to be our S sub 0 with an initial velocity of 80 feet per second. So this is going to be our V sub 0. Letter A, give the function. Okay, so let's take that function that we were given, that standard form up at the top, and let's write a function using the numbers that I now have. So S of t is going to be negative 16. I don't know what t is, so I'm just going to write t squared plus v sub 0. I now know that that's going to be an 80 times t, so 80 is that b value, plus s sub 0, and s sub 0 I know is a 100. And that's all that you need to do for part A. Part B is where you're going to use the graphing calculator. Since we've talked about that now in class, I will leave you to do that one on your own. Look at part C. Part C says that we're showing this coordinate 4.8, 115.36, and it says that it lies on the graph. Take a look at the figure down below the question, and you'll notice here that I have this coordinate marked, and it is the coordinate 4.8, 115.36. The question is, what does this mean? Well, if you'll notice, let's get those standard equations back. You'll notice that the old x is now a t, or a time. The old y, or f of x, is now an s of t, which is height. So t is time in seconds, s of t is height in feet. So now I know that my coordinate, that old x value, is going to be a time value. So I know that I have the projectile, or the ball, or whatever's being thrown or projected, is at 4.8 seconds. That particular coordinate marked is occurring 4 seconds that this thing has been in the air. And then the y part of this is going to be the height part of that. So you have 115.36 feet, because in our particular problems, height is always going to be measured in feet. So that takes care of letter C. Take a look at part D. Part D says, after how many seconds? Immediately, I know I'm looking for a t value. My answer will be a t value. Keep reading. After how many seconds does the projectile reach its maximum height? Maximum I know is vertex. Height I know is my y value. So basically, I'm asked for how long, what time, how long does it take to get up to the maximum? Now I know how to find maximum. We have a shortcut for that. The x piece, the h value of my vertex, is going to be negative b divided by 2a. Well, the h value is the same thing as my x value. The x value is the same thing as my time value. So I just need to find this piece. So we have Negative b, that's going to be negative 80, divided by 2 times my a, which is negative 16. If you reduce that, you're going to get 2.5. So to answer letter D's question, after how many seconds does it take to reach the maximum? It takes 2.5 seconds to reach the maximum. But keep reading, there's more on this question. What is the maximum height? How high does this thing go? Well, you remember in order to find the k value, we talked about this last class period, in order to find the k value, you just simply need to plug and chug. So we want to find s of, not s of t, but s of 2.5. So this is going to be negative 16 times 2.5 quantity squared plus 80 times 2.5 plus 100. If you enter that into your calculator, you're going to get a value of 200. 200 what? How high did it go? 200 feet. The last question that you're asked is letter F, and this says after how many seconds, so once again, I'm looking for a time value. After how many seconds will the ball hit the ground? Well, if you look at the picture of our little graphing calculator, the ball hitting the ground is right here. How high is the ball when it hits the ground? It has a height of 0 feet. So what you'll do is take your equation from part A and plug in a 0 for the height part of that. So this is part F. Plug in a 0 equals negative 16t squared plus 80 times t plus 100. Now I'm not going to take the time to finish this up, but the directions say to determine the answer graphically. So this is where you're going to go to your graphing calculator. You've already learned how to find x-intercepts. So you'll just simply need to find that x-intercept, and that will tell you the x piece of that x-intercept will tell you the number of seconds that it's going to take for the ball to hit the ground. And there you have it. I will see you next class period. Have a great evening.